Assalamualaikum and good day everyone. This video is about the summary from our group research paper, which is a new semantic mining approach for detection ventricular tachycardia and ventricular fibrillation. This presentation will include me, Maizatul Maiza, Nur Nabila and Nur Ain Hanani. This is the background for the ventricular fibrillation. Ventricular fibrillation is a type of abnormal heart rhythm. For your information, during ventricular fibrillation and disorganized heart signal, it can cause the lower heart chamber to quiver uselessly. The quivering means that your heart is not pumping blood out to your body. As a result, the heart doesn't pump blood to the rest of the body. This is the ECG graph for the people that have a ventricular fibrillation. Then, for the ventricular tachycardia, it is a heart rhythm disorder that will caused by abnormal electrical signal in the lower chamber of the heart. This condition may be called VTAC or VT. As we know, a healthy heart normally beats about 60 to 100 BPM. In ventricular tachycardia, the heart beat faster than normal, usually about 100 or more BPM. Most of the cases of ventricular tachycardia is caused by the heart disease itself. Okay, this is an ECG graph for people who have ventricular tachycardia. For the important research in this study, it is about a new method called semantic mining that is used to characterize VT and VF episodes by extracting their significant characteristic based on the frequency, damping coefficient, and input signal. The semantic mining techniques was capable of completely discriminating between normal rhythm of VT and VF without any false detection, and also it will distinguish VT and VF episode from one another with a recognition sensitivity of 94.1 and 95.2 for VT and VF respectively. This is the three objectives that we have found in this paper, which is to distinguish between the normal rhythm, VT and VF episode with a higher accuracy, shorten the time taken to analyze ECG signal for the patient, and last one is to reduce the rate of patient misinterpretation between VT and VF. Okay, this is the relevant question that related to the objective of this paper. The important concern that this work has raised is if misinterpretation are likely to arise while diagnosing a person's disease. Such things should be avoided since they can be hazardous not only to the patient but also to the doctor in the future. As we all know, if a doctor make an error in treatment or diagnosing, he or she may be held liable in a medical malpractice lawsuits. All medical professionals, including doctors, surgeon, nurse, or therapists, are legally obligated to protect their patient from harm.
Hi, my name is Nur Nabila. Okay, now I will proceed our presentation about scientifically valid argument. Semantic mining is used to characterize VT and VF episode by extracting their significant characteristic and classifies them as one of three types of rhythm: normal rhythm, ventricular tachycardia, ventricular fibrillation. SM technique was compared with four existing techniques, which is phase-based reconstruction, threshold crossing sample count, the K nearest neighbors rule, and the multifractal singularity spectrum. Sensitivity and specificity informs us how well these four techniques perform in classifying the ECG episodes correctly. The specificity can tell how well the techniques perform in detecting the absence of characteristic in a signal. In other words, the technique can describe whether a VF episode was classified as being neither N nor VT and vice versa. Okay, next is evidence. Table 2 shows about comparison of the semantic mining with other existing methods. The MSS technique produced the highest specificity and sensitivity. Compared with the other four methods, followed by propose SM and K nearest neighbor technique, which result in slightly lower specificity and sensitivity values. Although the specificity and sensitivity of MSS was the highest, the MSS used longer ECG episodes for analysis compared with SM. The same observation was found for K neighbors technique, in which they used much longer ECG episodes. A longer duration analysis was improved the detection accuracy, but because VF is life-threatening and must be detected quickly, longer signals may not be feasible, and the analysis must work efficiently with data from a short period of time. This data shows that our proposed method using semantic mining not only has a high sensitivity and specificity, but also uses shorter episode duration than the other four methods analyzed.
Okay, now we're going to moving on the methodology, which is the block diagram. So the input would be the ECG data, then we do the ECG filtration and binary decomposition, then we do the parameter extraction, which is consists of natural frequency, damping coefficient, and also input parameter. Then we do the ECG classification, and the output will be normal, ventricular tachycardia, and ventricular fibrillation. Semantic mining is the reduced order agent model that can be used to describe the oscillatory behavior of a system by monitoring the behavior of patterns of the semantic concept. Next, the flowchart. So the input would be the ECG signal data. Then the first process is ECG filtration and binary decomposition. So we go to the next process, which is the is it the signal inside the frequency range? If yes, then we do the parameter extraction. If not, then we go back to the ECG filtration and binary decomposition. So the parameter extraction, is it follow the specification? If not, then we need to do the parameter extraction back, and if yes, then we can classify the ECG signal into the normal, ventricular fibrillation, and ventricular tachycardia. Then for the output would be the ECG classification. Filter process is necessary to overcome the noise due to the electrode motion, power line interference, and baseline wonder, which will affect the ability to recognize the ECG signal. T-wave with high frequency characteristics similar to QRS complex could also affect the ability of the ECG recognition system. The filtering process works as follows, which is the first step is the mean value is subtracted from the ECG signals. Second step is a moving average filter of order 5 is applied to eliminate the high frequency noise such as muscle noise. Then finally, a band pass butterworth filter with a pass band from 1 to 30 Hz is used. A pass band from 1 to 30 Hz was chosen because the power spectra of the N, VT, and VF signals are reported to be within this range. For conclusion, the semantic mining method is capable of recognizing the ECG patterns and can accurately distinguish between the normal, ventricular tachycardia, and ventricular fibrillation. It has superior detection time when compared with the existing method because it analyzes shorter ECG episodes. Findings show some potential weakness of the process of semantic mining technique, which resulted in slightly lower specifically and sensitivity values compared to the MSS technique. After all, the process of semantic mining technique had conducted validation and the training phase in order to evaluate better performance. The results show that the semantic mining algorithm is computationally efficient and is well suited for the real-time implementation.